Hello, today we'll be going over day 13 of the Leetcode May challenge, which is titled Remove K Digits. So in this problem, you are given string num. In this case, we can have our string num equal to, in the example, 1432219, and an integer k. Let's have our integer k equal 3. So in this example, what we want is that we want to remove k digits from the number num, or from the string num, to make it the smallest it can possibly be. And so in this case, if we move 432, we get number 1219, which is left, which is the smallest. Now, to solve this problem, we don't actually want to remove k digits from num. Now, to solve this problem, what we actually want to do is we want to create a new string called s of size num.size minus k. Basically, what we can see is that after removing k digits from num, or in this case, after removing 3 digits from num of size 7, we will have a number, in this case the solution, 1219, of 4 digits left. So therefore, the size of s would be num.size minus k, the amount of digits that will be remaining. Now, we want to set s equal to an empty string to start out with. And what we actually want to do is we can use the observation that if I have a number, let's say a 4-digit number, a, b, c, d, where a, b, c, and d are integers, and let's have another number, a prime, b prime, c prime, d prime. So in order to figure out what is less, we start comparing left to right, because a has the largest significance, as in this case, it corresponds to the thousands place, whereas b or c corresponds to the hundreds place and the tenths place. So a has the largest significance. So therefore, when comparing left to right, we first check. If a is less than a prime, then that means we know a, b, c, d will already be less than a prime, b prime, c prime, d prime. Only after we check this, if a is equal to a prime, then we will move on to b. We check if b is less than b prime. Then we will know a, b, c, d is less than a prime, b prime, c prime, d prime, and so on. So from here, we know that the first thing we check is a, the first digit, or the digit with the most significance. Then we check the second digit, and so on. So using this logic, what we can actually do is, so in this case, we can assume that we are going to have a number a, b, c, d of length 4 to this specific example. So we can assume that the last 3 digits will automatically be the last 3 digits of num. And we only want to be focused on minimizing the first digit. So in this case, because we want to minimize the first digit, that's our number 1 priority, then we want to minimize the second digit, which will be a number 2 priority. So by assuming, because we want our size to be 4 in this example, we can assume that 3 of the digits are already set to be the last 3, and we want to minimize the first digit. So we have 4 options. We want to maximize the amount of options to choose from. So since 1 is the minimum, we are going to add 1 to s as the first digit, and then we can essentially just ignore 1 from the rest of the array. So we have 4, 3, 2, 2, 1, 9 left. From this, we're going to assume that since we've already picked 1, we're on to our second element, and we want to minimize the second element. So we're going to pretend that these 2 will be the third and fourth elements, and we just want to focus on minimizing the second one. In this case, we pick the minimum value, which is a 2, so we add that to s as a second element, and now we have 2, 1, 9 left. Again, we set the last value 9. We assume this to already be an s as the fourth element because we want to maximize the third element. So in this case, we pick 1, and then we are left with a 9 left. And in this case, since it's the only integer left, we can add 9 over here to form our answer s, and then we can print this out. Now let's go over how we can code the solution. So one thing which we can easily do at the beginning is we can write if num.size is equal to k, then we can just return 0. So what this is basically if we have our num size and k is equal to it, meaning that we have our string and we're removing all of the elements in the string, we can just simply return 0. And the next thing which we want to do is we want to create an integer temp equal to num.size minus k. What this basically is the size of the new string s, which we want to create. We can then initialize our string s as empty. From here, we can create two variables, counter and another variable called already picked. So basically what the counter variable is that it is a counter telling us that after we pick the minimum of the first element, we want to ignore all the elements before it. Because then we know that all the elements before it will not be the minimum, so we don't want it. So after we pick the minimum of the first element for our string s, we want to move on to the rest of the elements in the string, as I have shown in my solution. So what this counter does is it basically stores the index of the minimum element. What this already picked variable does is basically tells us how many elements are left that we need to pick. So from here we can go into our for loop for our main function. What this for loop here does is that for each value from I to temp is basically the size of the string which we want. So basically each time we go into this for loop, each time it iterates, we're going to add a character to our string. We're going to add a number to our string, basically creating the string of size temp which we want. Here I've created a character called min, which is a size 9. Basically, remember that we are going to be getting elements in the form of characters from the string, because we're going to add each character one by one to our string s. So here I have a minimum set to 9. Basically what this does is that we're going to compare each element size of the string which we have. We're going to compare it to this, and then if it is less than min, we're going to set it to the new min to find the minimum element in the set size we have. So from here we want to go to which elements in this string do we want to check. So what this here does is basically it's the indexy where the minimum element is after we pick it. So in this case, we have a counter equal to 0. So we start at the beginning and then we go all the way to the position. What this is basically the position where we leave the amount of elements which we need left. So basically remember in the example when we had 4 elements which we wanted. What this will basically do is that from here to here, this will basically tell us we can pick the minimum within this section of the string while leaving 3 elements left, which are guaranteed for spots B, C, and D. And basically what we want to do is, if num at position j is less than min, then we want to set min equal to num at position j. Basically what this here does is it helps us find the minimum, and then we're going to set counter equal to j plus 1. The reason being so is once we find the minimum, we know that all the elements before it were not the minimum. So once we have found one element, we can move on to finding the next elements without overcounting that. Now over here, what we are going to do is we're going to set already picked minus minus. This means that we have picked an element, so at the end, instead of leaving, for example, 3 elements after we've picked one, we only need to leave 2, because now we're going to move on to finding the second element. Then we're going to set s plus equals min. Basically, s is the string, so we're just going to add that character to s. Then at the end, one thing which we need to keep track of, keep careful count, is if we have something like this. In this case, we have a trailing 0. However, 0 to 0, 0 is just the same as 200. So we need to remove all of the trailing zeros. So in order to do this, we can create a string called s prime, which we set empty. Then we can create a bool trailing equal to true. So we want to remove all of those zeros that occur before the first element, which is not a 0. So here we can go through. Here we can write that if s at position I is unequal to 0, remember we have to use the character form, trailing is equal to false. What this basically tells us is, so while the first elements are 0, it's not going to do anything. Once the element we're at becomes not a 0, that means that there are no longer any more trailing zeros, and then we can start counting the elements from that point on and the ones after it. Then from here we can write if not trailing. That means that these are no longer trailing zeros. We can add it to s prime. Then at the end, you can write if s prime is equal to nothing, you're just going to return 0. That means if there's nothing left in it, at the end, we're just going to return 0. But if not, then we're going to return s prime. One error which I actually made in the beginning when writing this code, which I didn't catch, was we have to set already picked equal to temp. Because remember, if this confused you, already picked is actually the amount of elements which we have left in the array, which we want to fill into S. It is not K, but it is actually the size of S. So if we submit this, we can see that it is accepted.